Thanks to Ploy for letting me know that this video was missing. So here we've got a table showing us a number of bacteria in this solution at different times. We're told the population's growing exponentially. And so straight away from that, I know that I can have an equation that sort of might fit the model. A times B to the T plus C. And here, instead of Y, I could actually use P. All right, so from 2 hours to 4 hours, our population tripled. And from 4 to 6 hours, I hope that it tripled again, and I could check that. So let me clear out what I've got here. About 450 times 3 does in fact give me my 1350. So it looks like every 2 hours we're tripling. And so that lets me know that my power of B is going to be a 3. I want to figure out my initial population. So if I go back to times 0, I'm going to divide by 3 and get 50. And I can use these things to help me figure this out. So here we're tripling. And now, okay, so times by 3. Remember, I don't want to write in the area. I want to use my space under the question. So B, we know that P of 0 is 50. And if I also have that P of T fits this sort of formula, then I could say that P of 0 is, so that's definitely going to be A plus C. And generally, thinking that I'm tripling here without adding anything else, then that lets me know that my C value is 0 and my A value is the 50. So A is 50, B is going to be 3, and let's test that out. So if I had P of 1, then I would get 50 times 3 to the first, which gives me 150. P of, let's test out 6. Ooh, this is not going to work because that's not P of 1, that's P of 2. So it's every 2 hours that this is happening. I really want this to, because it's tripling each time, I want to leave this as a 3. But with the having it happen every 2 hours, I'm going to incorporate that up with my T. And instead of just saying T, I'm going to say T divided by 2. So now if I plug in the 2, I get 3 to the first, which will give me 150. If I plug in my 6, 50 times 3 to the 6 over 2, that's going to be 50 times 3 cubed. So let's test it out. 50 times 3 raised to the 6 over 2. And hopefully I'm going to get 1,350. And sure enough, I do. So because it's not happening every hour, but happening every 2 hours, I'm going to incorporate that in with my T. My C I'm not going to have at all because I can see that I'm just tripling every time. So that implies that my C is going to be equal to 0. My A is going to make my initial population. And now I'm going to divide by how often I'm tripling. So I'm tripling every 2 hours. So this is sort of like my time period. And I don't know, I don't want to use P over there, so maybe I'll call it R. All right, so after 1 day, I'm going to have population of 1 day, 50 times 3 to the half. I know that's the same as 50 times the square root of 3, but I can also just say 3 raised to the half. And it'll be some number between 50 and 150. And we get about 86. I'm going to round down because I have not actually hit 87 bacteria. So I'm going to approximate that to be 86 bacteria. All right, to the nearest hour, when am I going to hit the population mark? So, oh, this is not in hours, this is in days. Sorry, not in days, this is in hours. So after 1 day, I'm not putting in a half. I'm going to put in 24 over 2. So this is incorrect. That's why we need to read carefully. All right, come back. So I'm going to have 50 times 3 to the 12th. That's going to be a really big number. All right, 50, so 26,572,050 bacteria. I'm not rounding to 3 significant figures here because this is an exact value of bacteria. All right, so now to the nearest hour, when will the population reach the billion mark? So I want my population to be 1 billion. So there's my millions, 100,000s, equals 50 times 3 to the t over 2. And now I can use logs to solve this. So first I'll divide by the 50. So a billion is 1 times 10 to the 9th. And then I'm going to take that and divide by 50. And I'll get my 20 million. It's 1, 2, 3, yep. So 20 million. I can also think of that as 2 times 10 to the 7th. That's going to be 3 to the t over 2. So t over 2 is going to be log base 3 of my 20 million. So let's do that. Log base 3. And I come into my answer and then I can just go up and hit my enter. And now I'm going to multiply by 2 because I want to get the t by itself. Okay, so I can see that this implies that t is about, let's say, 30.6 ... At the 30th hour, I will not have hit a billion yet. So I have to go to the 31st hour to reach a billion bacteria. So I'm rounding up here because if I round down, I will have less than a billion.